Okay, let's get started. So welcome everyone to this session. My name is Xavier Coulon. I work at Red Hat. I work on JBoss tools and JBoss Developer Studio, which is what I showed yesterday. Today I'm going to show something completely different. That's something a personal project that I started more than a year ago, and it's about using Lambda Expressions to query a data store. So it will be about querying MongoDB with Lambda Expressions in Java. So what's the idea behind this? So what I'm going to do this afternoon, it's Saturday afternoon, so I'm going to give you like a story. This is the journey of this work that I did. And it started, I was riding my bike near my town, so it's very flat land. So I could think about something else, and I was thinking, okay, maybe how can we make something? We have Hibernate and JPA. I have these HQL, JPA-QL languages to query database. There are some other APIs like criteria. And I was thinking, well, maybe there's something else we could do with Java 8. At the time, Java 8 wasn't even released, but I thought, oh, there will be Lambda expressions. Maybe there's something I can do with Lambda expressions. And actually, Lambda expressions are type safe. So that's something that I was really interested in. And the benefit of using Lambda expressions is that you really describe the what and not the how, which means you really express what you want to retrieve when you write a predicate. You don't explain how you need to retrieve your data. You just write what you want to get, okay? So that's something like this. Let's say we have a user U, and we want to retrieve every user who has first name equals John and last name equals Doe, or every user whose username is JDoe. And I thought, okay, maybe we could have something like this, and we could say, okay, I have this user collection, because MongoDB uses collections, not tables. It's about the same thing, but it's collections in the terminology of MongoDB. So we could have something like this, user collection, and we want to find every user who matches this expression, and we want to get a list. And so this is where this idea began, and this is what I want to show you today. So I gave a name to this project. It's called Lambdamatic. And Lambdamatic has two building blocks. The first one, it's about metamodel generation. So if you were there before, we had a session about annotation processor, which is what I'm going to use. And then we have Lambda expression analysis. So let's get with the first block, metamodel generation. So this is really close to what JPA2 provides. We can start with an existing domain class, some user. It has some fields, some attributes, first name, last name, username. We put some annotations at document, and we say that users are stored in a collection named users. And we have this annotation document field. And so using an annotation processor, we can get something like this. We have this user underscore class, which is a metadata of user, and it has some document fields, which are public, not private, and of type string field, not string. Okay, we can do something else as well. We can generate a collection class. So that's another thing. We have this user collection class, which extends the Lambdamatic Mongo collection, EMPL. And basically, it takes, in its constructor, you have this Mongo client. So when you will work with this user collection, it has an access to MongoDB. So if we come back to the first piece of code that I showed you, if we do something like this, user collection.find, etc., well, the collection is this user collection that we just generated before. And more interestingly, the variable u is of type user underscore. So you're going to express write your Lambda expression against this metadata class. And so you can have something like u.firstname because it's a public field. But at the result, you will retrieve a list of users, which is what we want to get. So using Metamodel has some benefits. yeah, you may, okay, sorry about this. Yeah, you may think, okay, why do we have string field here and what not just string? So Metamodel has some benefits. Let's take an example. I have this bike station class, which is something I will show you later in the demo. So we have this bike station class, and it has a location field. So location is something that comes from Lambda-matic. It's just a simple POJO with two fields, latitude and longitude. So it's something you can use if you want to do geolocation, geo searching. So we have also this bike station underscore class generated by the annotation processor, and it has a location field. And this location field is an interface which has a GeoWithin method, which takes a set of corners, an array of locations. So basically, the idea with MongoDB, you can perform some geolocation queries, and you can say, okay, this is like a rectangle, a square, or whatever form, and give me every bike station located in this area. As you can see also, this location field is an interface. It's not a class. And actually, that's something that needs to be noted. We are not going to retrieve all data from MongoDB and perform a query in memory in the JVM. We are just going to, because we don't want to retrieve all data. It's not what we want to do. So we don't need to implement any business logic here. But at the end, what we can do with this metadata class, we can express this kind of query. We can say, okay, we want from the bike station collection, we want to find every station S whose location is within some corners. And as you can see, we have something very meaningful and very type safe. So this is the first building part. This is the metamodel generation. Now, that's the funny part which begins. Analyzing Lambda expressions. So when I came back from my bike ride, the first thing I did was, taking a shower. But then I went to my editor and I wrote some code. And I said, okay, I'm going to write this kind of code. This is, again, the example I showed before. I'm going to put a breakpoint and try to evaluate, try to see what we have for this expression. So if you know Eclipse, you know that if you don't have any caret before filter expression here, it means that you don't get anything. And actually, the only thing I could see was this org.lambdamatic.example, etc., user service, $lambda $1. And I thought, oh, shit, what can I do with this? So I did a bit of digging, and I found some information. And actually, what you can do with this expression, which had no metadata associated with it, you can do something like this. You can retrieve the class. Well, there is a write replace method, which is not really exposed in the IDE. But you can, using reflection, you can invoke this write replace method. And at the end, you get something like this. You get a serialized lambda, which has many interesting things. Two of them, actually three of them, but I forgot to show it. They are captured arguments. But you get this implementation class and implementation method name. And so now I know where to look for my Lambda expression. It's in the user service class, and it's implemented as Lambda $0 method. So anyone knows how Lambda expression works at the compilation time? So basically, the compiler is going to generate some extra methods in the class where your Lambda expression is written. So you will have some Lambda $0, Lambda $1, Lambda $2, etc. Methods, which will be invoked dynamically when your code is executed. So now we know where to look at. So the next step is reading the bytecode. So this is what you can get if you use JavaP command line. You can print your bytecode. And if you use something like ASM, which is a library to read or write, but I wanted to read bytecode, you can read this kind of bytecode, and you get something like this. This is actually what the compiler is going, no, sorry, this is what the compiler meant as behind the bytecode. And this is what the JVM is going to execute when this Lambda expression should be invoked. But yeah, keep in mind one thing. We are not going to execute the bytecode. We just read the bytecode to understand what was behind, what was supposed to be. So we have something like this, which is correct. I mean, it's exactly what's would happen if it was executed. But we can certainly simplify this kind of statement tree, because as you can see, we have some return true, some return false, etc. So the first thing we do, we have these branches, and we keep only branches that return true, because actually this is what we want. We want something that matches. So everything that returns true is what we keep. So we get to something like this, which is more compact, still correct, but still not optimal, because we have more things. We see that u.firstName appears 3 times, u.lastName appears 2 times, etc. So we can certainly make something simpler, because we don't want to send this kind of query to MongoDB. It's too complex. So I remember that I had some course at university about Boolean algebra. So I got back to, well, I didn't keep my books, so I looked on internet again, and I found some Boolean algebra rules that I could apply. So I did put everything in some code and try to try to see everything that would match against what we had before, to try to simplify as much as possible the code. So this is using like heuristic, trying to see everything. Every time some rule apply, I carry on and dig on until I find something that has the smallest score, which is computed. So to find something as simple as possible. Well, I can tell you it's been quite a nightmare. I pulled my hair many times. But at the end, I started from this, and I got something like this, much simpler. And if you remember what we started from, it's actually the same thing. We get the same result, interestingly enough. Quite a lot of work. Yes, quite a lot of work. And yeah, I was happy. Okay, so we have 2 building blocks. We have this metadata Metamodel generation. We know how to retrieve the code, the meaning of your Lambda expression. So now we can use it together and query MongoDB.
Do you do it in an automatic way? You translate those expression, you simplify those expression automatically, or would this just manual work?
Okay, so the question is, is it automatic or not? Yes, it's automatic. So,
yeah, so that was that was the point of the thing, right? Because I think in general, if I'm not wrong, making those expression simpler could be an NP-complete problem. I think it's only kind of heuristic.
Okay, so yeah, it could be something like too complex to compute. Is it your question? Okay, yes. So actually, what the program does is it tries to simplify as much as possible. So we start from an existing formula or expression or some tree, and we see every pattern that matches, and we see if there are any Boolean rules that apply. And if so, we carry on. We find something, a new form for which we compute a score. And if it's interesting, we carry on until there is nothing else we cannot go further, and we stop for this branch. And we keep every form that we did, every intermediate form. So we avoid any loop, any cycle, because it will be. And well, from my testing, I didn't do some testing with huge expressions, but as soon as I find something, for every expression every new form of expression that I find, if I I do some analysis on it, and if I know that I cannot further simplify, the program stops with this result. Otherwise, we will try every branch. With, well, it's something finite. I mean, at some point, you're sure to get some results. It's just, it may be very fast or not as fast. Depends on the complexity of your code.
In theory, if you want it to be really optimal, then it would be probably potentially exponential complexity.
Yes, probably.
But like, we probably use a curve of heuristic, which is quite sufficient with bytecodes, right?
Yeah, well, from the result I get today, it works, yeah. And one thing I didn't mention is that once this computation is done, this kind of lambda expression retrieval, the result is cached. So you don't have to do it every time. The thing is, we have these captured arguments, which are like the parameters, external parameters, and you get this lambda expression form, and we just apply the captured arguments and throw the query. So, querying MongoDB now. So there are two things, integrating with MongoDB Java driver version 3 and integrating with CDI because I wanted to run this thing in Wildfly. So the first thing was MongoDB Java driver integration. So I started with MongoDB version 2, but then I switched to version 3, which is more interesting because even if it's not released yet, it has this notion of, it has been redesigned internally, and it has this concept of codec and codec providers. So you can provide some codec for filter expression and documents, and so with this codec, you can convert Java objects into BSON document, which is what MongoDB takes in and out. And actually, doing this kind of thing allows me to skip the public, default DB objects, which are just DTOs. So yeah, MongoDB Java driver, by default, is going to return or to take DB objects, which are just some kind of maps of attribute values, etc. But it's not really interesting to manipulate. So I've got this thing here. So just to illustrate, we have our business code. We have some lambda expression, which is basically what we want to query. We send it to the MongoDB Java driver, which is going to use a filter expression codec. And this codec is going to transform this lambda expression into a BSON document. This BSON document is sent to MongoDB, which is going to make it process the request and return a BSON document as a result. Once again, MongoDB Java driver is going to use its codec, and it's going to use a document codec to transform the BSON document into a domain document or list of domain documents, which can be now returned to the business code. Okay, CDI integration, that's pretty straightforward. I have this annotation processor, which generates some meta classes, and I just need to add another one, which is a producer for my bag station collection, for example, and I just return this. Of course, it requires that Mongo client and Mongo client configuration can be injected, and so I have some producers as well for these two classes. And now it's time for a demo. So let me just see how I can. Okay. Oh, that's annoying. Okay. So I have this code here in JBoss Developer Studio. So the idea of this application is we have, so New York City has some bikes. You can rent a bike and go from one place to another. And interestingly enough, there is a URL where you can download a file, a JSON file of all the bike stations and get the address, geolocation, number of docks available, number of bikes available, and a status to see if this station is in service or it's not in service. So the idea is to make a sample application where we have this bike station stored in MongoDB, and we want to display a map with all markers showing where the stations are. So we have this bike station class here. We don't need actually this kind of annotation, XML root element. Anyway, so it's a document. Bike stations are stored in a bike stations collection. And we have many fields, including location, as I showed before. We even have an AUM enumeration here. And what do we have? We have this, well, at the beginning, I made something with JAX-RS. And so I had this JAX-RS endpoint, which took a set of location, which are a query parameter of the request. But I changed my code and make something with WebSockets. So we can use WebSockets, and we have something like this. So the endpoint URL will be /bike station. We have a decoder which is going to decode the location that is passed as a JSON document. So we know the corners of the screen, which are basically the location, the point where we want to see the bike stations. And we have an encoder which is going to transform back the bike stations into a JSON document. And so what we do here, we get this find bike station method, which is invoked when a message arrives. And we get this list of locations, which are going to be passed to my bike station storage service. And here, we just do this kind of query, which is very simple. We say we want to retrieve any station whose status is in service and whose location is within the corners of the screen. Very straightforward. Now, on the website, sorry, we have this index.html page, which is basically nothing else but showing a map here. And we are going to use leaflet and some bit of jQuery. And here, what we do is when the page is ready, we create a map here using this code. We open a WebSocket at this location, and we say that, well, as soon as the map is moved, we are going to refresh the markers on the page, and we do it at the first time because we want to display something straight on. And basically, that's it. So let's go to the code and see. So we have this thing here. And we can see that we have a few bike stations at the south of Central Park. And as soon as I move, I get everything which is refreshed. So we have this WebSocket connection which is used. And actually, I should show you something. This is the console here. Oops. And so you can see queries are sent here. It's quite fast, actually. Okay. So this was my short demo.
Excuse me, what is the WebSocket good for in this use case? Because like WebSocket is for like server notifications basically, isn't it? While here the direction is just one direction. The client asks the server, so you basically do not need a socket, and it's not on the client side, right?
Yes, right. We could have some JAX-RS endpoint. Yes, that's what I did at the beginning. But I thought, since we have something, as you drag your map, you have many events that are sent, and so many requests are sent. So I thought it would be more interesting to have WebSocket instead of having a HTTP connection that needs to be open and closed every time. Or maybe I could keep my HTTP connection open. But
So you used it just because you could?
yes. Yes, I could do it, so I did.
Thank you.
Okay, yeah, it's not. I'm not using WebSocket to push data from the server. Not in this case. Maybe I could do something like this, some more advanced use case like.
It's not important for like
Yes. Yes, that's it. I forgot to show it. If you click on this. So yeah, we could have something like WebSocket. If you have this, you're with your mobile and you say, okay, maybe I want to go there, and suddenly there is no bike available. You could have something that changed on your screen, for example. That could be WebSocket with push notification. That could be a use case, but it's not implemented here. Okay. So back to the slides. So what's the status for this project? It's totally experimental. It's something I did on my free time. So it's, yeah, that's basically what I showed you here is what works. There are a few things where you can insert data, but it's not nothing more for now. The code is on GitHub. It's on github.com/lambdamatic. So if you're interested, you can clone it, fork it, store it. There are actually two repositories, one for the code and one for the example application. Unfortunately, there is no. You need to build the code to run the application because there is no. I didn't push on any Maven repository the existing code. And if you're really interested and you want to participate, I suggest you open issues and to discuss about API and feature requests. And that's it for this session. I'm a bit early, but we have time for questions. Yes?
Could you get back to this example of the query? The last example you showed us with the code, with the query.
In the code or in?
When you query for status and for
okay.
location being within this.
Yes. That's somewhere here.
Could you show the lambda?
Yes. Okay, let me just.
So here you analyze the lambda code. Yeah?
Yes, it's analyzed the first time it's called.
You go into bytecode, and
yes.
when there is a nested function called like here, location geo within, so you have to also to go into that function and analyze that code too.
That's why it was an interface, wasn't it?
True. So the question is, do I have to analyze the code within GeoWithin?
Analyze this code recursively to go deeper and deeper as the.
Well, no, there are some acts in my code actually. If I know that this location field is this location attribute here is of type location field, when I call this GeoWithin method, I know what I need to do with my codec afterwards to make BSON document. I don't need. It's just actually.
Status method call into MongoDB query specification query language. You need to see what's inside.
No. Okay. So what is inside? Inside this method, you just get corners, which is a captured argument. So it's something that comes from the caller.
There's also some code for checking if the
Actually,
point
phrase
is.
that code does not take.
But actually, it's an interface. I don't need any implementation for this.
Yeah, but this is a query for checking. What's further in this line? It's cut. So what's next?
Okay, let me just put it on 2 lines.
All right. So you
Let's-
the list.
Yes.
Before running the query. So
No. No, what I do is when you call this find, when find is called, there is a lambda expression which is going to be analyzed at the first time. And so the first time we get this kind of tree of what is called. So we say basically we want a status which has this in-service value, and we want a location within some corners, which is something that which is a captured argument.
building a syntax tree of this
Yes.
lambda.
Yes, that's
And so you have to build the branch for this GeoWithin function also.
yes, it's part of the tree, but there is nothing inside. It's just an interface. It's just a name. So basically, there is nothing to do. It's just, I say, OK, I want location geo within some captured arguments. That's all. And then when I use this codec to conf... Yes, I have, so it's a tree. So I have this visitor, which is going to look at the tree and say, OK, we have geo within here. OK, we make a BSON part, which is something...
I didn't get that this geo within is a special case just for this translator.
Well, yes, it's a case. It's one case.
It's not a normal function on the
Well,
syntax for
well, actually, geo within is something that exists in the MongoDB terminology, so I use the same name. But you could have something... Actually, if you have something like status equals in service, that's another way to write your query. So I need to look at every method call or every, well, equals is something similar. And then my codec is going to say, OK, this part, this is how it is to be written in BSON for a query. So yeah, everything can be a special case if you like. Yes?
I noticed that in the model classes, you used you introduced your own annotations at document something.
Yes.
Wouldn't it be reasonable to reuse JPA annotations for that?
JPA annotation?
Yes.
OK, OK.
New set of annotations.
OK, so the question is, there is a new set of annotations. Shouldn't we use existing JPA annotations? So yes, maybe we could use entity annotations. But I didn't want to have this kind of at table annotation because it doesn't match.
All annotations or not
Okay.
all attributes in those annotations would
Yeah.
be applicable or applicable.
Yeah.
But then still, it could be more sort of easier to understand for newcomers.
I wanted to have something that matches MongoDB terminology. So in MongoDB, you talk about collection, document, so I wanted to have something similar.
Okay.
So, but again, that's something that can be discussed. It's a choice.
That's why I brought this question.
Yeah, sure. And I think actually Morphia has this at entity annotation, but it's not JPA annotation, it's Morphia annotation, but they use the same name at entity. So, yeah. Any other question?
one more.
Yes, sure.
Why did you introduce a string field class instead of string?
Okay, so why did I use string field and not string? So one thing that is not implemented yet is with MongoDB, you can say I have a string in which matches a value in an array. So my idea was maybe we could have something like you could say u.first name in, and you pass an array of values and it matches. So
Yeah, you need something like this for integers, strings, and so on.
yes, so I'm still not fully convinced about this choice actually, but I made this string field and actually I don't really use anything besides equals for now. But I was more interested in having this location field type, which allows me to use the GeoWithin method. So yes, it's still, it needs to mature, I guess. Okay, any other question? Okay, well, thank you very much then. And I think there was a link for the feedback if you want to provide me with feedback, or maybe not me, but organizers. It was, okay, maybe not this way. Yeah, this way. Okay, thank you very much.